This video will provide an overview of the lessons for week 28, days 52 through 56. This week, students will continue their work on task 5, Extreme Living Solutions. First, on day 52, students will design an experiment in order to test the prototype of the product they designed. Then, students will follow their procedure and their safety guidelines to build and test their prototype. Each student will do this individually so they can share and compare their results with the rest of their group. Next, students will create posters to show off their products and explain how they work. On day 55, students will consider data and products from other groups in combination with their own group's data in order to redesign their products. Finally, to end the week, students will continue adding to the class concept map for the unit. Let's go through the key points from each day, starting with the lesson for day 52. Students will start the week by writing plans to test their prototypes with an experiment that generates data. This continues the design process that students have been engaging with throughout Task 5. Last week, students brainstormed and created a design for their prototype of a product that maximizes or minimizes thermal energy transfer. Now, they will build and test their prototypes. In Task 4, students designed an experiment to investigate changes in temperature. Just as they did then, students will now write a procedure for an experiment, design data tables to organize their results, and consider safety precautions. This time, students will be designing an experiment to test the prototypes they build for their designs. In their project groups, students will discuss how to actually test their prototypes. Here, students have the option to either actually build and test a physical version of their prototype, or to test it virtually using the Energy 2D interactive heat transfer simulation from Concord Consortium. A separate video included with the slides for day 52 goes into more depth regarding these options and how to use the simulation. Regardless of which option they choose, on page 7 of the student handout, students will draw and label the setup for the experiment to test the success of their prototype. They may use Tinkercad, Google Drawing, or just pen and paper to draw the diagram of the setup of their experiment. At the top of page 8 in the student handout, students will write their procedure, being sure to include safety considerations and how they will collect their data. It's important for students to understand this part of the process. We live in a time where it's easy for anyone to market and sell products without much evidence that they actually work. One of the lasting skills and ideas we want students to take away from science is the importance of testing and gathering evidence. It's not enough to simply build a prototype and claim that it works for some scientific reason. Students need to prove that it works. On day 53, students will do just that, following their plan to build and test their prototype. As they did for their experiments in Task 4, students must consider what safety precautions are necessary when conducting their tests. Remember, students should not be using sources of heat at home. If the product they have designed involves a heat source, they should probably use the Energy 2D interactive heat transfer simulation from Concord Consortium to test their prototype virtually, or come up with another way to test it. Review the excellent safety video from Task 4 with your students. Each group must review safety rules and make a list of safety precautions specific to their own prototype test before they can perform their experiments. After reviewing their experiment design and procedure, students should build their prototypes, then perform their test to collect data. All of their data should be recorded and organized at the bottom of page 8 in the student handout. Each student in each group should build their own prototype and test it, recording a video of the process in order to share the results with the group. The videos should include what the product is and what its purpose is, how the prototype was tested, and what the results of that test were. Students should then review and comment on their group members' videos, which is easy to do in Padlet or Flipgrid. After building and testing their prototypes, students will create posters to present and explain their products. Now that students have tested and shared the results with other members of their own group, they should incorporate their other group members' data into their own design in a continuation of the design process. Although students may create a physical poster, there are many digital platforms that students can use to create a poster as a group. A separate video included with the slides for day 54 provides several options and how to use them. Regardless of how the poster gets made, it should contain an explanation of how the product works, as well as data from the test of the prototype. The poster should also include an explanation of the results, using knowledge of thermal energy transfer. The explanation should explain not just what the results were, but why those results were obtained. What factors related to thermal energy transfer caused those results? How did the product reduce or enhance thermal energy transfer? Remind students that if they are not sure, they can return to the article, videos, and simulations from Task 4. Especially if this task is being done asynchronously, it's important for students to create a video presentation of their poster so that other groups can learn about their product, prototype, test, and results. It's crucial that students review the work and ideas from other groups. They will provide valuable feedback through their comments, but just as importantly, they can learn from others' data to improve their own products. As other groups share, or as students watch the group poster presentation videos, each student should individually record features about other groups' designs that might also improve their own products. It's important to include the data that support these potential improvements. How do students know that these potential improvements will actually make their products better? This data will also be used in the culminating project. On day 55, students will continue the design process by incorporating new data to improve their products. After viewing other groups' posters and results, students will have an opportunity to redesign their own products by using the data that other groups presented. Not all the products or data from other groups may be relevant. It's a good exercise for students to prioritize the most relevant ideas and data for their own products. Which other products were similar, or used the same concepts about heat transfer from the unit so far? Those are the products to focus on. This prioritizing and redesigning is an important step of the design process. Design is an iterative process. It uses past data to repeat and improve with each repetition, incorporating new information and ideas. Students will meet in their groups to decide what they can use from other groups' data. They will be able to include the best characteristics of all the designs to make their own products even better. Page 10 of the student handout provides important questions for students to organize the ideas they will incorporate. First, students should consider what other products worked well or best to meet the criteria of the problem that group was trying to address. Even if a particular group's product or problem was unique to that class, it's likely that other groups' problems or products were similar or used similar concepts regarding heat transfer. It's important for students to go beyond just naming other groups' products, however. They must include the evidence to support the claim by citing the data and observations from the experiments that groups performed to test their products. Next, students should compare their notes in a group meeting. What did they learn from the other groups? What are the best characteristics for their product now that they've seen others' ideas? They should combine at least 3 pieces of data from other groups with their own data. This will ensure that they can revise their product to better address the criteria and constraints of the problem they chose to solve. After the group meeting, students will independently reflect and plan how to improve their own product and prototype. What adjustments can be made to the product so it better meets the problem's criteria and constraints? Can the type of materials be improved? What about the mechanism or structure of the product? Students can once again use Google Drawing or Tinkercad to draw a label diagram of their revised product. If students truly believe that no revisions are necessary or possible, they should instead justify why their design cannot be improved at all. It's likely that with some more consideration, all students will find ways to improve their prototypes. Once again, students will need to create a video to present and share their modifications. How did they change their product's design? Why were those changes desirable or necessary? Finally, on day 56, students will take time to reflect on their learning so far and add to the class concept map. Start by asking students to consider the process of redesigning their product. Why are revising and redesigning beneficial? Then, give students time to discuss in groups the new concepts and connections they can add to the class concept map. What questions can they develop? Make sure that students have access to the interactive bulletin board so they can use the academic vocabulary and sentence props as they make connections to the cross-cutting concepts of energy and matter, scale, proportion, and quantity, and patterns. Then, work as a class to add to the class concept map. Finally, ask students to make connections to the culminating project. Those are the major tasks and key points for week 28 as students continue their work on Task 5, Extreme Living Solutions.